that has fractions in it. And what we want to do is get rid of the fractions, because fractions are stupid.
No.
No, they're not stupid. They're not very fun to work with. A fraction of the time, they're not bad. But the other portion is bad. It was, wasn't it? But I'm proud of myself for it. What? Oh, and by the way, in case you haven't noticed, all the math department, we're all wearing the same thing except for Mr. Reyes. Mr. Reyes apparently doesn't realize that green is green and red is red. We all wear green ties. Even the females are wearing green scarves. He wore red.
These women does sound like Christmas again.
What's the common denominator between 3 and a 4? 12. So what I'm going to do here is I multiply everything by 12. Here's why. Because that would be the common denominator for everything. If I multiply everything through by 12, I'm going to do this long form to show you why this happens. If I distribute the 12 to everything on both sides of the equal sign, which is legal, because what you do to one side of an equal, you have to do to the other, otherwise, numbers are jealous. It's like if you get a new Lego set, your brother wants a Lego set. Otherwise, all hell breaks loose. Bad things, all right? So what happens is, by distributing through, you get the following. 12x over 3 plus 12x over 4 is 12 times 7 over 4. Now, I haven't changed anything at all. I'm doing this the long way because now if you look at it, you have 3 separate monomials that can be then simplified. 12 over 3 simplifies to what? 4. 12 over 4 is, and 12 over 4 is, you're done. What I'm doing here is I'm figuring out a way to eliminate the fraction easily. Yep, but not the greatest common factor, the least common factor. Because that way, if you do a greatest, if I did, let's say I did 24, then I'd have to simplify something at the end. It would have bigger numbers that just take longer. But by getting your least common denominator, I know that the least common denominator would have been a 3 times 4. And we'll, go ahead. Yeah. So here, this one has a 3, it needed to be multiplied by a 4. This one had a 4, it needed to be multiplied by a 3. And so on. That's all it is. That's it. Or, go ahead and distribute through. It's really easy to see these numbers, but when you get to terms, you'll see why we list them out. You know who gets what, things wrong. All right? Let's try another one.
It's amazing. It's amazing.
I just shaved my head.
Thank you, Brandon.
Try again.
My favorite. Sometimes.
Yeah, I shaved my head for about 6 years. And then I let it grow back. So again, I want to multiply this by something to get rid of the fractions. So what would be the least common denominator of a 3 and a 5? 15. So the least common denominator between a 3 and a 5 means I multiply everything by 15. Well, in the back of your mind, if you want to start thinking of it as, instead of just 15, think of it as our common denominator is 3 times 5. Well, the first fraction already has a 3, it needs a 5. The second fraction has a 5, it needs a 5. The last fraction needs them both. And now let's distribute combined like terms and solve. So if you distribute out, let's see here, we get 5x minus 3x minus 6 is 30.
Oh, you have to, never mind.
You have to distribute.
Just waiting to see if you caught that.
No.
So you have to distribute the negative.
Yep, always. You always distribute your negatives, and then it's just a matter of a two-step equation. Add 6, 5 minus 3 is 2, divide by 2, and you got 18. Now, the other thing you can always do is go back and double check your work. So, what's 18 divided by 3? What's 18 plus 2? 20. What's 20 divided by 5? What's 6 minus 4?
Excuse me.
Yay!
Exactly, but you don't have to do any homework. You just go home and take it
No,
out.
I have to.
It kind of looks like Good Cop when he drew his face back on. Hi, everybody! No? No Lego movie reference? Hey-o!
No humanities.
Okay.
You just have to read it.
All right. Well,
I don't know what you have first.
let's step it up some.
Speech homework. Speech is a fun class.
Where excuse me. What's that? What about the 7?
7
Well,
over 1.
7 over 1. What would you multiply everything by? Yep. And that's the idea by showing, you know, how I was saying that one fraction had the x minus 2, the other one didn't. So this one wouldn't have to be multiplied, this one does, this one doesn't. That's the idea by writing out, when I wrote out 3 times 5, the first one didn't need a 3, it needed a 5, and so on. By knowing which terms are already there, you don't have to do that double step of simplification. Can, it's just a waste of time. So here, I have 5x over x minus 2 equals 7 plus 10 over x minus 2. The common denominator here is going to be what? X minus 2. So I'm going to multiply everything by x minus 2. By doing this, I am eliminating the fraction. Now, again, I want you to, don't write this first step out, but I want you to see what's happening by distributing out this x minus 2 to each term. It allows for the fractions to go away because they create monomials that allow the terms to drop. Since this fraction already had the x minus 2, it'll go away. This one needed it, this one did. That's why we can just say 5x equals 7x minus 14 plus 10. And all I did there was just distributed the x minus 2 right away.
You don't want to actually.
No, you don't have to have that stuff. If you want to, go for it. Well, eventually, you're gonna have a common denominator that's gonna have 3 terms to it, as opposed to that you have to multiply out as opposed to just 1. So it'll get messy. Excuse me. So let's see here. I get negative 2x is negative 4. X is 2. Uh-oh. Does that work? It doesn't. Why? So what's your answer? No solution. It's a solution, but it's not a solution. So this is technically a no solution. The reason that this doesn't work is because if you put 2 in the denominator, you get 2 minus 2, which is 0, and you cannot divide by 0. Make sure you double check your answers on these things, because sometimes your answer is not an answer. I know it's the weirdest thing to say like that, but it's a solution, but it's not a solution. What's so funny?
This piece of paper your straw.
I'm probably done drinking it anyways.
You were causing trouble.
Once I'm starting to shake,
I think I should split you 2 up. So what you're saying is you cheat off each other?
Sure.
Oh.
It's a stimulant.
Probably like the 2 causing trouble causing people in the whole school.
And we should do it.
Well, it's fun.
This one's gonna have an extra step to it.
Great.
Excuse me. So I have 4x plus 1 over x plus 1 equals 12 over x squared minus 1 plus 3. Which means I probably need to factor one of my denominators to figure out what my my common denominator will wind up being. So the x squared minus 1 is a difference of squares. That's not terrible. X plus 1, x minus 1. So can I just go ahead and say that I need to multiply everything by x minus 1, x plus 1? Because that's what would be the common denominator here. So if I do that, the first fraction doesn't need the x plus 1, it needs the x minus 1. So we're going to have a 4x plus 1 times x minus 1. The 12 is good. It already had them both. They had them both in a multiplied out state, format. The 3 needs them both. But am I going to write it as x plus 1, x minus 1 to distribute out? Or am I going to write it as x squared minus 1? I'm going to do that, just because I know it's going to be easier in the long run. Sometimes if you have those little shortcuts like that, by all means use it, because it just quickens it up. So you have to FOIL out the left. We get 4x squared minus 4x plus x minus 1 is 12 plus 3x squared minus 3. So move everything to one side to set it equal to 0. Always keep the highest degree positive where it's at. So the 4x squared is larger than the 3x squared. So I'm going to move everything to the left. Actually, before I do that, I'll do this. I have 4x squared minus 3x minus 1 is 3x squared plus 9. So subtract the 3x squared, subtract the 9, and I get x squared minus 3x minus 10 is 0. Which means you have to do what? Factor. No solution. Done. I'm out. What times what is negative 10? You add together to get negative 3. Negative 5 and 2. Very good. So you therefore get, yes sir?
I'm confused. The way you set it up, like, I don't think you can do that because you kind of like multiplied like some stuff.
Yeah.
And then nothing to the other.
Well, what's happening here, and I'm not writing out that step, is if I take this, if I'm taking this and I'm multiplying all of this by x plus 1, x minus 1. Remember, I'm getting 4x plus 1, x plus 1, x minus 1, over x plus 1. What drops? Equals 12 x squared minus 1, x squared minus 1. What drops? That's what I'm doing. I'm just skipping that step. What I'm doing here is, this already had an x plus 1, I didn't have to write it down. It needed the x minus 1. That's why I don't care about writing it out, because it's going to go away anyway. That's why it already had both of them. That's why I don't even bother to write it down, because it's going to go away anyway. This one needed them both, that's why I write it down. That's why I'm doing it that way. I'm skipping that step because I don't need it. Because I can vocalize it. Okay? That's how it works. I hate the back button. It never works.
I really don't have any idea.
So, I have possible zeros therefore at 5, negative 2. Which means we have to check them to see if they work. So what you want to do then is just double check your answers, see see if you're gonna get answers that work. So let's see, 21 over 6. And let's see, that's 12 over 24 plus 3. That's 18 and 3, 6. That's 3.5. Isn't it? And that's 3.5. So this works. If I use -2, I get -8, -7. -7 over -1 is 7. Then I have 12 over 3, which is 4. 4 plus 3 is 7. So they both work. Always double check your answers. One of them might work, one of them might not work. Both of them might not work, I don't know. This? Okay. What do you do if you have this?
Just write my solution.
Cross multiply. Why is it that you can cross multiply here, but you can't cross multiply here?
Because there's a 3.
Okay.
There's a 13.
More specifically, why can't I do it? Because there's an addition.
Exactly.
So what do you do if the 13 is there?
Then you have to get a common denominator. If it is only fraction equal fraction, there's nothing else, just a fraction equaling a fraction, that's the only time you're allowed to cross multiply. That's it. Whereas everything else, we've had to get the common denominators and go through it. But if you ever have fraction equal fraction, cross multiply and go. Okay? So if you have something that looks like this, that is fraction equal fraction. You don't have to get common denominators, because when you get a common denominator, all you're doing is cross multiplying with this style. What happens? Life, good job. If I divide both sides by x minus 1, what do you get? What's 2 squared? 4. What's 4 minus 2? What's 2 divided by 2? 1. What's 2 minus 1?
Yes.
What's 1 divided by 1? It's all these numbers. So really, whenever it is just fraction equal fraction, cross multiply, and then try to simplify. Okay. I don't think there's anything else. I don't have to do this one. I know there's a couple. I'll give you a couple tricky ones. But for now, I'm not going to go too crazy.
As long as I get everything else done before once, I should be able to get the flex.
I'm going to ask her about the
I think she's just as tired as we are, but she just like, I don't understand why she keeps giving us this schedule. She's just gonna complain. She's gonna complain about having to grade it. Like, we're gonna be at state this weekend, so she's gonna be grading.
You're staying together.
No, we're going home Saturday after. Saturday. It's gonna be so Caitlin and
Oh,
Dave.
hold on. Sorry, 71.
Let's just take a minute.
All right, Danny's over here.
Caitlin Alex. The freshman. I can't remember. She's so much fun.
Who did that? 7, but math is hard.
You know who else is pretty funny? Me.
Yes.
You said that's debatable.
You had me think for a second, like, wait, did I say that wrong? Yeah, no, I thought I counted 7. Work on those. Is the computer unfrozen now? I apologize for. Sorry about that. That was kind of funny.
It was probably the best part of my day.
You know, I am glad that
You can make my day
I'm just whatever.
by freezing my keyboard.
It wasn't frozen. It was just
It was pretty cold.